Alright, so today we're going to look at linear programming, which is section 7.6. This is based off of section 7.5 where you're graphing inequalities. So we're going to graph inequalities today. Okay, so there's 3 guidelines for linear programming that you need to know. The first one is you have to graph your constraints. Okay, your constraints are your equations, your inequalities. Then you have to find your vertices, and then you have to test your vertices to find an optimal solution. Yes, okay. So if we're given these 5 constraints of z equals 3x plus 2y, x is greater than or equal to 0, z is greater than or equal to 0, x plus 2y is less than or equal to 4, and x minus y is less than 1. We need to graph those. So z equals 3x plus 2y, that's your linear programming equation. Okay, so that's the equation that we're going to test our points in. These other ones are our constraints. Okay? So we know that x is greater than or equal to 0. It tells me when I'm looking, let's see, oh, wrong one. That's y. Try again. X is 0 on your y-axis, so if we're looking at values greater than or equal to 0, we're only looking at values on this side of my graph. That's what that tells me. And I know if y is greater than or equal to 0, y equals 0 at your x-axis, and so if it's greater than 0, we know we're looking for values just up here. So the only quadrant we care about where we have both values is our first quadrant. So that's the only one we're going to worry about. Then for these other 2, we have to graph these equations to figure out what they look like. So if I solve this one for y by subtracting x from both sides and then dividing by 2, I get y is less than or equal to 2 minus x divided by 2. And you graph that. And if I subtract x from the other side and then divide by -1, end up with y is greater than or equal to -1 plus x. And so we're going to graph those on our graphing calculator to see where we can get. Do you have calculator number 3? Oh, I have number 2. Okay. Make sure when you put the x divided by 2 part, you put it in parentheses, otherwise it won't work. Alright, so if I graph my first line, since I only care about my first quadrant, I know that it crosses my y-axis at 2 and my x-axis at 3. So this is my line. And since y is less than that, I only care about the part underneath. Yeah. You can just do a sketch. We're sketching them at first. That's the first part of your linear programming, is to graph your constraints. If I look at -1 plus x, I know that that crosses my y-axis at -1 and my x-axis at +1. So that's my graph. And since it's y is greater than, I shade above. So the only section I care about is this inside section on my first quadrant. I just sort of sketched that because then it makes it look a little easier. And then the second thing it told us that we had to do was that we had to identify our vertices. Okay, so I have a vertex here, 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 and here. Okay, so I know that this point is the point 0, 2. That's one of them. If I look at my graph, I know that this other point is 2, 2. Nope, sorry, 2, 1. This point down here is 1, 0. And my origin is obviously 0, 0. You only care about the parts where your graph is crossing the parts that your constraints tell you about. Okay, and I knew that my linear programming equation was 3x plus 2y. So that's where I'm going to test these points. So my first point I'm going to test is 0, 0. So if I plug in 0 for x and 0 for y, I end up with z equals 0. If I plug in 0, 2, then I end up with 4 to be my answer for z. If I plug in 2, 1, 3 times 2 plus 2 times 1, end up with 8. And if I plug in 1, 0, then I end up with 3. And so those identify my minimum and maximum values of my linear function. So I know that my min is at 0, 0 because 0 is my smallest number that I get. And my max is at 2, 1 because 8 is the biggest number that I get. Make sense? Everybody got that? Well, I appreciate your honesty. Alright, so for the second one, my linear programming equation is 4x plus 5y.
I don't get the graph part.
The graph part. Okay.
That'll get.
Okay. Well, we'll graph another one. So x is greater than or equal to 0. Okay, so x is equal to 0 where? My y-axis, yes? Everyone agrees x is equal to 0 on your y-axis. So if x is greater than 0, am I shading to the left or the right? To the right, because that's where my x values are bigger than 0. Okay. If y is greater than or equal to 0, where is y equal to 0?
At 0.
At your x-axis. Okay, and if it's greater than or equal to 0, am I shading up or down? Up. So which quadrant has both of my colors then? My first quadrant, so that's the only quadrant I care about. So if I draw a really big first quadrant, then that's the only part I really care about. Okay, then if I graph my last constraint, x plus y is less than or equal to 6. In order to graph that, I have to solve it for y, so I'm going to subtract x from both sides. So y is less than or equal to 6 minus x. That's the constraint we're going to graph. Okay, if I graph that, I see that it crosses my y-axis at 6 and my x-axis at 6. And since y is less than that, am I shading above or below? Below, because you shade below for less than. So this section of my first quadrant is the only section I care about. That section, that triangle. Then we have to identify my vertices. My vertices in this case, since it's a triangle, it has 3 vertices. And then you just plug them in. So 0, 0 is one of my vertices. 0, 6 is another one, and 6, 0 is the last one. Alright, and my constraint is z equals 4x plus 5y. Okay, so we'll plug in my constraint. So if I plug in 0, 0 first, I get 4 times 0 plus 5 times 0, which equals 0. Makes sense? I plug in my second constraint, 0, 6. I get 4 times 0 plus 5 times 6, which is 30. And if I plug in 6, 0, I get 4 times 6 plus 5 times 0, which is 24. Okay, so where is then my min at? 0, 0. And where is my max at? 0, 6. Alright, so let's do one more. Okay, well that's my linear programming equation, 5x plus 7y. I know that if x is greater than 0 and y is greater than 0, what quadrant am I in? My first, okay. So I know I only care about my first quadrant. Okay, and then I need to graph those various constraints, but in order to do that, they need to be solved for y. Okay, so if I solve this for y, I get y is greater than or equal to 2 minus 2/3 x. If I solve this one for y, I get y is greater than or equal to negative 15 plus 3x. If I solve this one for y, I get y is less than or equal to 4 plus x. And if I solve the last one for y is less than or equal to 27 fifths minus 2 fifths x. Okay, so let's graph those constraints in a graphing calculator. Graph them, let's go. Make sure you put your fractions in parentheses, otherwise it won't come out right. Alright, so my first line, 2 minus 2/3 x. I see that that crosses my x and y axis at 2 and 3. So I know it's going to look like just that bottom corner. And because it's greater than, I'm shading above. And I'll shade it in a minute. But yeah, there's a lot of lines. Okay. I look at my second line. I see that that crosses my x-axis at 5. And goes up. And if I look at my third line, I can see that that crosses my x-axis, or my y-axis at 4. And then goes down. And then my last line crosses my y-axis at 3 and goes up. And so this inside area of this strange looking four-sided figure is the part I care about. So if I identify my vertices, I have 1, 2, 3, 4, 5, 6 of them. Because it's everywhere it crosses any of the axes and anywhere the lines cross. So there's 1, 2, 3, 4, 5, 6, 6. Where's the 7th one that I'm missing? Oh, yep, you're right, 7. There's a lot of lines. Cut me some slack. Alright. So I see one of my points is 0, 2. That's this one down here. If I keep going up my y-axis, I also have 0, 3 and 0, 4. Then if I go up, I see that one of my lines crosses at 1, 4. That's this point right here. If I keep going, 1, 2, 3, 4, 5, 6, 6, 2 is another one of my points. 5, 0 is a point, and 3, 0 is a point. Yep, and then we plug them into my 5x plus 7y. So 5x plus 7y is my constraint. So if I start with 0, 2, then I have 5 times 0 plus 7 times 2, which gives me 14. If I go with 0, 3, 5 times 0 plus 7 times 3 gives me 21. If I go with 0, 4, 5 times 0 plus 7 times 4 gives me 28. Okay, if I go with 1, 4, 5 times 1 plus 7 times 4 gives me 33. Next one is 6, 2, 5 times 6 plus 7 times 2, which gives me 44. 5, 0, which gives me 5 times 5 plus 7 times 0, which gives me 25. And then the last one is 3, 0, so 5 times 3 plus 7 times 0, which gives me 15. Okay, so which one's my min? 0, 2. And what's my max? 6, 2. Alright, so does this make more sense now that we've done a couple more? Yes, makes some sense? Yes?
See.
Okay, you have 7 problems to do today, 13 through 20.